Students, in this lecture I am going to explain you about the working of an inverting and non-inverting amplifier, and I am going to derive the gain of these amplifiers. Okay. Now let's say about what is an inverting amplifier. Inverting amplifier is an amplifier where the output of this inverting amplifier is 180 degree out of phase with the input signal. So now let me draw the inverting amplifier. So here we have taken 741 op amp, 7416 op amp, and as you previously you have studied about the pinodes of 741, pin number 2 is nothing but pin number 2 is the inverting input, and pin number 3 is the non-inverting input, and pin number 6 is nothing but the output. So this is the inverting input, non-inverting input, and this is the output. So for an inverting amplifier, the output, whatever the input you give in the inverting terminal. So I am giving the input in this terminal pin number 2. Whatever the input which I give in this input, the output will be inverted. So let me draw the input waveform. Input waveform, this is the input, and I am drawing the output waveform. So as I said, the output voltage will be out of phase with the input signal. Output signal will be out of phase with the input signal for an inverting amplifier. I hope you understand the working of an inverting amplifier. Now, let us derive the gain of an inverting amplifier. So inverting amplifier means we give the input in the inverting terminal. So I am connecting source voltage at the input side. This has to be connected to the inverting terminal through the resistance R1, and the non-inverting terminal will be grounded. And this inverting amplifier with the negative feedback using op amp. So the inverting amplifier with negative feedback, so we have given a feedback resistor RF, and this is the output voltage V0, and we have an input voltage Vs. Now we are going to derive the gain of this op amp. As you all know that gain is equal to output voltage divided by the supply voltage. Considering op amp to be ideal, op amp to be ideal, we have the concept of virtual ground concept, wherein the potential at the non-inverting terminal is 0, thereby hence the potential at this node will also be 0. And since the op amp is ideal, it has got high input impedance, so it will not draw no current. No, the op amp will not take any current, will draw any current. So the potential at this node will be 0. Okay. Next step, let us find the drop across this R1. So it is nothing but Vs minus 0 is equal to I into R1. Sorry, I have not written the current. The current through this arm will be through this resistance will be I, and since there will be no current flow through the op-amp. Since the op-amp is considered to be ideal one, the entire current moves through this side, so the current flow through this RF will also be I. Obtaining the voltage drop across R1, Vs minus 0 is equal to I into R1. So this can be written as Vs is equal to IR1. Let's mark this as equation 1. Coming to this side, let's find the drop across this RF. So here it is 0 minus V0 is equal to I into RF. I take this I, V0 alone. So V0 is equal to minus I into RF. Let's mark this as equation 2. So as per the gain equation, then substitute V0 by Vs, equation 2 by equation 1. So this is minus I into RF divided by I into R1 is equal to minus RF by R1. Hence the gain of a non-inverting amplifier is minus RF by R1. Hope you understand, you have understood how we arrive the gain of an inverting amplifier. Now let's move on to non-inverting amplifier. Let's move on to non-inverting amplifier. As the name implies, whatever the input is fed to this non-inverting amplifier, the output will be in phase with the input signal. So that's a non-inverting amplifier. Now let me draw the waveform of the non-inverting amplifier. So as I said, whatever input is fed to the non-inverting terminal, the output will be in phase with the input. Oh, I'm sorry. So it has to be said. So this is a waveform which shows the input and the output voltage. Now let's derive the gain of a non-inverting amplifier. So same circuit I am drawing. So when I say non-inverting terminal, we have to connect non-inverting amplifier, we have to connect the input in the non-inverting terminal. So I am connecting Vs over here. And this side, this part has to be grounded. Inverting side should be grounded. And as usual, you have a negative feedback. Let's mark this to be RF and this is R1. And as usual, you have in the earlier classes we have seen, we will give the supply to the IC plus VC, plus 1 minus VC. Now let's derive the gain of this expression. So as I said, based on the virtual concept, whatever virtual ground concept, so whatever the voltage appearing at this non-inverting terminal will be appearing over here. So this node, the potential will be Vs. So now I can simplify this circuit to be like this. Okay. So the circuit can be simplified like this, and by applying voltage divider rule, principle or rule, I can write Vs. What is the drop across this R1? Drop across R1 is nothing but R1 divided by the total resistance, R1 plus Rf into the total voltage, that is V naught. Okay. I can rearrange this equation. So V naught becomes Vs into R1 plus Rf divided by R1. I can further simplify this equation to be Vs into 1 plus Rf by R1. As you already know that gain is nothing but output voltage divided by input voltage. Output voltage is V naught, input voltage is Vs. I am bringing this Vs down. So we get V naught by Vs is equal to 1 plus Rf by R1. So finally the gain of a non-inverting amplifier is 1 plus Rf by R1. Hope you have understood the derivation of gain of inverting and non-inverting amplifier. Thanks for watching.